So today we're going to go into chapter 10.1, and it's going to cover solving systems of equations. Now, when we're doing solving systems of equation in chapter 10, I have to be very careful because we're not just going to do, any sort of equation. In particular, we're going to work with linear equation. There are going to be some parts in chapter 10 where we're going to do equations that are not linear, but for the most part, we're only going to be working with linear equations. It's only one particular topic. So we have a definition. Your book uses 3 different words. I'm going to combine them all together. A system of linear equations a system of linear equation is a set of linear equations involving the same variables. So what does that mean? The key words that we're looking for is a system, linear, and equations. Now, already we know what linear equations are, so we're already good with that. It's more so a system. All I'm going to be working with is a collection of equations. And in particular, these linear equations, they have a special property. Not only do they involve the same variable, but additionally, they involve the same variable but they have solutions in particular. So I'm sorry for that. So you want to think of it as just a collection number of equations. You have 2 equations, maybe 3, maybe 4, maybe 5. You have a numerous amount. We're going to be working with 2 equations just for this section, but then when we get to chapter 10.3, we're going to up the ante by working with 3 sections, 3 equations, 4 equations, 5 equations, etc. So, now that we're talking about this, when we talked about equation, we need to understand the solution. However, we need to understand the solution of our system of equation. So, another definition. A solution to the system. I'm going to call this star, just so it's easy to name. So star is a system of linear equation. The solution to star is an assignment to all the variables, that satisfy each equation. So this is a very powerful thing. When we're talking about systems of linear equation, not only do I have to satisfy the equation itself for these variables that I'm solving for, so I might have x, y, and z, but it's more powerful than that. These solution that I find out must be the solution to equation 1, equation 2, equation 3, equation 4, all of the equation in my system. And it's a very powerful thing you have. Because some of you guys might have realized that, hey, how can I guarantee a solution? I have 5 equations here. How do I know they're all going to be the same exact answer? Well, that's the thing. Sometimes you don't have proper solutions. Sometimes you have one solution. Sometimes you do not have a solution. All that stuff. So you have to be careful. In particular, let's look at an example of a system. Just so, you have an idea of how it works and everything, because we haven't seen an example of it. So, an example might be the system 2x minus y equals 5, x plus 4y equals 7. Right here. This is a system. I'm gonna call it system 1. I'm gonna give it a name. So system 1 has exactly 2 equations and 2 variables. Do not get too comfortable with that. We're gonna be working with systems that have maybe 4 equations, maybe 5 variables. In this case, we're working with the 2 by 2 dimensions, but maybe if we increase it, then things can, have different outcomes. Maybe we have to be worried about that. But we're working with the 2 by 2 case because it's very simple. So in this case right here, we have to find a value for x and y that satisfy both equation 1 and equation 2 for our system 1. So it has to satisfy this guy and it has to satisfy this y. It turns out that the solution is the x value 3 and the y value 1. Now, if you notice, I wrote it as an ordered pair. This is very important. You can also write it as x equals 3, y equals 1, but you have to be very careful. Be very careful if you write it the way I just did now. The reason why you have to be careful is if I have multiple solutions, I need to make sure I know which y value corresponds with which x value and which x value corresponds with one y value. Now, how can you tell these are solutions? Well, if you think of it graphically, these are going to be, let's look over here. Dun, 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 dun. Let's look at these equations on the graph. 2x minus y equals 5 and x plus 4y equals 7. So there's an issue with your graphing calculator is that you won't be able to graph these equations that simply. Now, if it's 2 dimensionals with 2 variables, x and y, you can graph it by clicking the y equals button, but you have to solve for y on both equations. So you have to do some work. All right? On Desmos, it works out nicely as long as you have those 2 variables, but in other graphing calculators, you do have to solve for y. So let's look over here. This is your solution. It is the intersection between the 2 lines. These are linear equations. They should be lines on as a graph. So the solution here is 3, 1. So we can identify this graphically. Now, I need more than that though. Graphing is a way you can verify to see if your answer is true. However, if you just put the solution down without showing me any work besides this, I used the graphing calculator, you're only going to get 1 point. I'm going to be honest. So we need to make sure we have a method of finding this. But before we even talk about the methods, let's talk about how these lines can interact. Types of solutions. Because it's important I discuss this. Well, if they interact, if they connect those 2 lines, like we saw earlier, we have the possibility that we have exactly 1 solution. We can have exactly 1 solution. The 2 lines, they meet at exactly 1 singular point when they cross. That is very important because our solution in this problem right here might be 3, 1, but that's still a single solution. It's an ordered pair in this case. It's the assignment x is 3, y is 1. Now, how else can 2 lines interact? Well, if you figure it out, sometimes the 2 lines, they don't have to cross. If they don't cross at all, we say no solution. You can have no solution. In this case, we call the system inconsistent. Sometimes we are not lucky. Sometimes the equation that we're trying to solve for, these 2 equations, sometimes there's no answer that satisfies both. You might find one that satisfies the first one, but then that doesn't satisfy the second one. Sometimes we don't get that fortunate. And in this case, our 2 lines will be parallel. And then the third one, well, they can connect at 1 point, they can never touch, or they can touch forever, infinite amount of times. solutions. This is very important. Infinite solution. We call this dependent. In our case, the two lines are the same line in our case. So generally, you have to find a way to describe your infinite solution rather than just saying infinite solution. I need to know what is the correct assignment. So these are our three types of solutions. And then now we're going to work with some methods. And these methods, you have worked with these before, but we can talk about them. So the first one is substitution. I'm hoping that everybody here knows the idea of substitution by now, especially since chapter 3 was all about functions. Or I'm sorry, chapter 3 was all about functions. We had to constantly substitute our x value in. So, example, let's take an example of a substitution problem. Let's do the system. Let's do 2x plus y equals 1. And then 3x plus 4y. Actually, I'm not going to do that one. Where's it at? X equals 3. And 2x plus 3y equals 54. For some of you guys, this might be your first time seeing it, but you do understand the idea of substitution, but maybe not with systems of linear equations. However, I'm hoping that by looking at this system, you can figure out what you should do in this problem. I'm going to leave you guys some time. Just pause it real quick and see if you guys can figure out what you should do to solve this system. Alright, if you figured it out, you notice that it says x equals 3 right here. Substitution requires you to plug things in. Well, I'm telling you x is equal to 3, so every x value over here, you should plug in 3. So if I were to plug 3 in, I get 2 times 3 plus 3 times, 3y equals 54. Now, why is this important? Why does this help us solve our system? Well, if you notice, I don't have two variables anymore. I don't have x and y in my equation anymore. Now I only have one singular variable. So if I can calculate it out, I got 6 plus 3y equals 54. Now my goal is to isolate the y or solve for y. 3y equals 48. And then y is equal to 16. Now, the moment you get here, this is not your solution. This is a part of your solution. Remember, we need the assignment for every variable. I only got the y right now. Well, actually, I have more than just the y. I have the x up here. So I have x equals 3. So I have the solution, or I have an assignment for each variable that satisfy my two equations. If I plug these in, I will get a true statement. If I plug in 3, 3 equals 3, that is true. If I plug in 3 and 16 here, 2 times 3 is 6, plus 16 times 3 is 48, which gives me 54. So the second equation is true. So my solution, I have exactly one solution, but the solution is 3, 16. The order does matter. You need to tell me what's the x value, what's the y value. So make sure you have that. And the way it's going to be working on tests, if you do not put the solution down, if you just tell me x equals 3, y equals 16, I'm not going to give you full credit. So make sure you have this final solution as an ordered pair. Alright, so that covers that. That's how we substitute. But what if I had a different system, like, let's say I had a system 2x plus y equal, let me use a different color so you don't get confused. What if instead I had 2x plus y equals 1, 3x plus 4y equals 14. This time, my system doesn't have a variable solved out already. So that might make things slightly more difficult. Then what can I do? I'm going to leave you guys to pause it and see if you guys can figure it out. Alright, if you tried it out, you might still struggle and everything, but some of you guys might have realized that you can solve for a variable. You can solve for x or y. Now, it does not matter what variable is solved for. I'm going to tell you, solve for the easier variable. You can solve for a variable on the top first equation, or the second equation, or the third equation if we do have a third equation. You can choose any of them. I'm going to choose the very top equation because there's an easy one right there. If you guys solve for x, you're going to get something like x equals, I don't know, 1/2 minus 1/2 y. That's too much of a problem for me to deal with. I don't want to deal with fractures right now. So instead of solving for x, what I'm going to do is I'm going to solve for y. If I solve for y, let's see, I subtract 2x to both sides. I have y equals 1 minus 2x. My new system, and I recommend you, when you guys show your work, you rewrite your entire system out. That way you leave less mistakes happening. You write out y equals 1 minus 2x. These are the same system, just different representation. 3x plus 4y equals 14. Boom, I have a new system now. This time I have y solved out, which now I can implement the idea of substitution. I'll plug this in for exactly this guy right here. Y is equal to 1 minus 2x. Why not plug that in? So now if I plug that in, I get 3x plus 4, 1 minus 2x equals 14. And if I solve this out, I get 3x plus 4 minus 8x equals 14. I get negative 5x equals 10. X is equal to negative 2. I am not done just yet. I have to figure out the y value. Now, I have to use this new value and substitute it into one of the equations. I could plug it into either this equation, or this equation. Either or works. One of them is going to be easier than the other. I'm hoping that you guys notice that if I plug it into equation, or this equation right here, I immediately get a y value. So let's plug it into that one. Y is equal to 1 minus 2 times negative 2. Y is equal to negative 2 times negative 2. That is positive 4, which is going to give me 5. So my solution is negative 2 comma 5. So that worked out nicely. We got a solution for that. Well, now I'm going to give you 3 problems, and I want you guys to try it out to see what you guys can get and whatnot. We know how to solve systems if I don't have it in y or x equals, but if it does, it makes it easier. So now let's work with these 3 systems. So I'm going to call this system number 1. These are going to be example practice problems, really. System number 1 is going to be x plus 2y equals 26. 7x minus 3y equals 12. System number 2 is going to be x equals y. 3x minus 3y equals 0. And then system number 3 is going to be y is equal to 2x plus 3. Y minus 2x equals 10. Go ahead and try these 3 systems out. You can pause the video and come back to me. I will talk about this in a few seconds. So pause the video. Alright, so if you attempted these problems, you'll notice something funky about some of them. So the first one, everything played out nicely. Let's try to solve for a variable for the top one. Because if I try to solve for the bottom, for the second equation, I might have some fractions, and I don't want to deal with that at the moment. If you try to rechange the system, I'd recommend you solve for x. If you solve for x, your new equation becomes x equals 26 minus 2y, and 7x minus 3y equals 12. Boom. So if you try to solve this out, you're going to be substituting this guy inside your x. If I plug that in, I get 7 times 26 minus 2y minus 3y equals 12. Distribute this out, you get 7 times 6, that's the 2. Boom, 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 boom. What is that? 162? Let me check real quick. Can't do the math at the moment. 182. 82. Let me fix that up so that looks nicer. 182 minus 14y minus 3y equals 12. Good. And then if I combine like terms, I get 182 minus 17y equals 12. Negative 17y equals negative 170. Y is equal to negative 10. I'm almost done. Now I got to solve for the x value. So I'm going to plug this guy in all the way up here. You can plug into any of the equation. Remember that. But I'm going to plug into here because it's more convenient that way. So if I plug into this equation, I get x is equal to 26 minus 2 times negative 10. X is equal to 26 plus 20. X is equal to 46. And then just to verify, we can graph it on decimals just to see if we have the right solution. X plus 2y equals 26. Maybe some arithmetic issue happened, but let's see. Minus 3y equals 12. 6 comma 10. So that means there was a slight math error. I'm trying to figure out where it happened in particular. Is this the right problem? 10. Ah, this is supposed to be positive 10. That's what went wrong. Okay. So a slight math error. So let's go fix that. Pretty sure you guys caught that, but let me go ahead and fix that real quick so we don't have any confusion. So this should have been 26, and I figured something was wrong. Minus 20, x equals 6. So our solution is 6 comma 10. All right, that covers system number 1. Now we go into system number 2. Well, I already have it in x and y equals, so you can actually choose which one you want to use. I'm going to use x. I'm going to substitute this y in for x over here. I'm going to plug that guy in. If I'm plugging that guy in right here, well, what happens is I get 3y minus 3y equals 0. 3y minus 3y, that gives me 0 equals 0. Wait a minute. I don't have a variable for this one anymore. It doesn't say x equals 2 or x equals 0. It doesn't even say y equals 0. What does this mean? This means I have infinite solution. The problem is, you need to tell me more than that. You need to tell me what solutions work. Because although you have infinite amount of solutions, only some in particular will work. How do I know what x value matches up with y? Well, let's think about it. If I had the x value 5, what would the y value have to be? Well, if you look in our first equation, it says x is equal to y, so the y value also has to be 5. So my solution is going to be, solution for this problem is going to be exactly all the x and y values such that x equals y. Boom. That is my solution. All the x values such that x is equal to y. Now, there's something called parameterization that you will learn more in Calc 3. But parameterization, your solution would look like you set x equals to a t. They like to use the variable t for time. And then y is also equal to x. Or you can say y is equal to t. Either or. This is parameterization right here. I do not expect that at the moment. I expect this at the moment. Eventually, we will work with parameterization. Actually, we will talk briefly about parameterization, but that's more so in Calc 3, Calc 2, and linear algebra. All right, moving into the last one over here. If you were to solve this out, you can substitute this guy in all the way for this y. Then I get 2x plus 3 minus 2x equals 10. Well, these cancel out completely. They're gone. 2x minus 2x. That's 0, so I get 3 equals 10. Well, this is a contradiction. This means that there is no solution. Your system is inconsistent. And this makes sense. The two lines, if you graph them, they are parallel. There you go. No solution. I do expect you to know what inconsistent means. And then if you ever go into linear algebra, if you have an infinite amount of solutions, they call this dependent. If you're ever curious. But don't worry about what that means for now. But if you do plan on going into higher level maths, that is what the terminology is called when you have infinite amount of solution. Dependent. Because x will depend on y, or y depends on x. Alright, that covers it for substitution. And then the last thing I want to talk about before we head out is elimination. Now, there are three main properties with elimination. I am not going to teach you how to do elimination, but I will show you three rules that you can use in elimination. The first rule is that you can rearrange terms, or let me say like terms. How about that? Terms column-wise. If you do this, you do not change the system at all. The system will stay the exact same. It's just a different representation. So let's do an example. If the system was x plus y equals 6, and then x plus 5 equal 2y, I can rearrange this system to be x plus y equals 6. That can stay the exact same, but the second equation, I can turn that into x minus 2y equals negative 5. Boom. I can rearrange that. Now, if you're looking through the PowerPoint presentation, this is slightly different than the Gaussian elimination. We will talk more about that next time. But the idea is that I can move around these terminologies, and I need to move around these terminologies. You should move around these terminologies. Boom. So that way, the x lines up with the x, the y lines up with the y, and the constant lines up with the constant. The next thing I can do in elimination is that I can add equations together. I can add the equations together. So, if I go back to this example, I can actually add these two together, and because they're aligned column-wise, x plus x, that's 2x, y plus negative 2y, that's going to give me negative y, and then 6 plus negative 5, that's going to give me positive 1. Okay? And then the final thing that we're going to work with is that we can multiply, and I'm going to use a big word, /scale any equation by a constant. Now, I put the s after equation because, again, you can add or scale any number of equations. I can add all three equations together. I can add two of the equations together and not add the third one. I can multiply the first equation by a constant. I can multiply the second one by a constant, but I don't need to multiply the third one by a constant. This will have a different form for your system, but it would only be a different representation. You still have the same system at the end of the day. So let's work with this guy right here. Boom. If I wanted to scale this, let's say x plus y equals 6, x minus 2y equals negative 5. If I wanted to scale, let's say, the second equation by 3, I can multiply the entire equation, yes, even past the equal sign. This will transform my new system into x plus y equals 6 and 3x minus 6y equals negative 15. This becomes my new system right here. I am able to do that. I only multiply the second equation. I can multiply both equations, or I can multiply them by different numbers as well. I don't have to multiply everything by the same constant. So, these are your three main rules for elimination that you will be using. Now, we're going to do some problems, And you should have an idea how to solve these problems. So the first problem I'm going to look at, let's see, let's work with, let's call this, let me give names for these. I'm going to call this system name, let's see, negative 3x plus 5y equals 1, 3x minus 6y equals 3. This system name is going to be, let's call this phi. That's a weird looking phi. Let me fix that up. Boom. System phi. I want you guys to give this an attempt, look at your three properties, and see what you can do. Now, I didn't show you how to eliminate just yet, but think of the title of the topic, eliminate. Why is it called eliminate? So, you can pause the video. I'll give you guys a few seconds and I'll be back. Well, if you notice, if you try to rearrange the terms, you don't need to do that because the x's line up with the x, the y's line up with the y, the constant lines up with the constant. So we don't even need to rearrange the terms at all. Then, moving on to the second one, can we add the two equations together to simplify this? Well, let's try adding them together. If I were to add this together, negative 3x plus positive 3x, well, that's deleted. That is gone. 5y plus negative 6y, well, if I add those together, I get negative y. And then 1 plus 3 is going to be 4, which means y is equal to negative 4. Now, once you have found a variable, because the x's eliminated in this problem when I added them together, I have a variable solved out for y. I have y equals negative 4. Once you have this down, now you can go back and substitute to any of the equations to see what the x value is. So let me put back the x's. So I'm going to plug this into any of the equations. I'm going to plug into the first one. Either or works. Whatever one's easier for you. If I plug into the first one, I get negative 3. Oops. Negative 3x plus 5 times negative 4 equals 1. Negative 3x plus or minus 20 equals 1. Negative 3x equals 21. X is equal to 7. We got all of our variables. So now my solution after elimination is going to be 7 comma negative 4. Well, let's step up the difficulty a bit. So this one we just simply added. We didn't need to use the last property, but let's step up the difficulty. Now, what happens if I have another system number 2, which is going to be, let's say I have 3x plus 5y equals negative 20. Let's see what else. 2x minus 10y equals 8. So go ahead and try to use any of the three properties to see what works out and what doesn't. Sometimes it plays out nicely, sometimes it does not. So if you had tried it, you realize that if you add these two together, and I'm going to give this a name. I'm going to call this, I don't know, C. System C or psi, whatever you want to call it. But system C, if I try to solve for it and add them together, nothing eliminates. So that's a problem. I need it to eliminate. They're already rearranged, so that means the only thing I can do left is to scale one of the equations. So if you notice, you can actually multiply this entire equation by 2. If you multiply it by 2, you get 6x plus 10y equals negative 40. You have to multiply that negative 20 out. Some people forget that. 2x minus 10y. And notice how I am rewriting the entire system. This is a very good skill or habit that you guys need to, I guess, use when you're doing these problems. Otherwise, you'll make mistakes. So now let's try adding them. Let's see if anything happens now that I add them. I get 8x. Oh, these guys, they cancel out. 10y plus negative 10y, that's 0. Equals negative 32. X is equal to negative 4. So if you notice, your goal is to have the same coefficients, but one of them should be positive, one of them should be negative of each other. That is how we're going to be scaling. We're going to scale so that we can have those results. You can eliminate the y, you can eliminate the x, whichever variable is easier. Now I have x equals -4. I can plug it into any of the equations. I can plug it into this one. I can plug it into this one. I can plug it into this one, the original one. I'm going to plug it into this original one over here. It doesn't matter. You're going to get the same result. So 3 times -4 plus 5y equals -4. Or, not -4, I'm sorry. 5y equals -20. Yeah, my stylus is being weird. Give me a second. -20. Oops. -20. That's -12 plus 5y equals -20. That's 5y equals -8. Y is equal to -8/5. So your solution is going to be -4, -8/5. That is a 5. So we found a solution to the system doing elimination. We had to scale that first equation by 2. Well, let's go on with another one now. This is more and more practice. I think the more practice, the better for these problems. So now we're going to work with 2x plus 4y equals 20 and 2x minus 5y equals 2. And I don't know what to call this one. Let's call this system, let's say gamma. System gamma. Go ahead, give this one an attempt, and we'll come back in a few seconds. All right, if you noticed, if you tried to add these two together, that's not going to work out. You're going to get 4x plus 1y, and then none of the variables got eliminated. So what you would need to do to eliminate it is multiply one of the equations. I'm going to choose the top one. Multiply it by -1. You need to have different signs. So if I multiply by -1, the new system is going to turn out to be -2x minus 4y equals -20. 2x minus 5y equals 2. This is my new system. And then now, if I try to add these two together, I get these cancel out. Now I'm going to be left with -9y equals -18. Y is equal to 2. I can plug it into any of the equations. I'm going to plug it into this one right here because I feel like it. So 2x minus 5 times 2 equals 2. 2x equals, or 2x minus 10 equals 2. 2x equals 12. X is equal to 6. So we have 6 comma 2 is my solution. Boom. So we're looking great. We can do that. And then we have one more type of problem that I want you guys to see. That way we can call it a day. The last problem that we're going to look at is, what if I have this kind of system right here? 2x plus 5y equals 4. 3x minus 4y equals 6. I'm going to call this system, I'm running out of names now. It's called system delta. System delta. Go ahead and pause the video and see if you guys can figure it out. Well, if you notice that if you try to add these together, nothing eliminates. If you try to scale one of the equations, you still can't get the same coefficients. So in this one, this is for my critical thinkers, you would actually have to multiply or scale both equations by different value. If you wanted to eliminate the x, you would scale the first one by 3, second one by 2. If you wanted to eliminate the y, you would scale it by 4 and 5. I'm going to scale the y so I don't have to multiply by a negative. Because if you notice the y terms, one of them is positive, one of them is negative. I don't have to multiply by a negative value. I'm going to multiply this one by 4 and multiply this one by 5. If I do so, my new system becomes 8x plus 8x plus 20y equals 16. And then the other one is going to be 15x minus 20y equals 30. If I try to add these together, you'll notice that this becomes 23x. These guys are eliminated, equals 36. X is equal to 36 over 23. Yes, you can have a fraction. There is nothing wrong with having a fraction. All right? Oh, it's not 36. It's 46. I apologize. This is not a fraction. So this is 46. X equals 2. I was hoping we would work with a fraction. And then I can plug it into any one. I'm going to plug into the top one over here. You can also plug it into the ones up here if you want to. I'm going to plug it over here. So I have 8 times 2 plus 20y equals 16. 16 plus 20y equals 16. 20y equals 0. Y is equal to 0. Your solution is 2, 0. So that covers it for substitution and elimination. So we look at we learned the different methods. We learned 3 different methods for solving systems. The first one we look with, which we didn't really talk about as much, also is reconnecting. So I'll give it some time to reconnect. What's going on? Well, I think that's a good stopping point, but the methods are going to be graphing. We solved it by graphing. The next one was substitution, and the last one was elimination. So I will catch you guys next time. Take care. Bye.